Buddy. Just wanted to give you a brief rundown of my book, Java for Programmers. Wanted to focus in on RMI and JNI. We've already discussed the idea about using remote method invocation, but it'd be really nice to be able to do invocations of native methods on a remote platform. So I thought I would give you a brief rundown on how to do Java native method invocation. We talked a little bit about the Common Object Resource Broker Administration, known as CORBA, which enables us to call foreign language programs using the Object Management Groups, or OMGs, Inter-Object or Protocol, IIOP. This allows you to do non-Java invocations for remote machines. RMI gives you the native protocol for invocations, but one thing I'd like to be able to focus a little bit on is a direct call to native code from within Java, and this gives you a CORBA-like capability without having to deal with the internet TCP/IP stack. So one of the things you'd like to be able to do is some kind of systems programming. So for example, if you want to access the serial port, it'd be really good to be able to make those invocations directly from within Java. If you wanted to do other things that required C code, because Java doesn't have the API for it, you can extend the Java API. And you can get speed out of this. You can find mechanisms for interfacing to a variety of different kinds of hardware that you might discover: USB devices, scanners, video cameras, microphones, multimedia devices in general. And so there's lots of reasons for using JNI, and there are a couple of alternatives to JNI, and I'd like to discuss those. JNI is the older interface that requires that you compile for every platform and then load the native libraries dynamically at runtime. But it leads to several problems, and these include a lack of portability, an impedance mismatch between the data structures of a C program and a Java program, and general bypass of security. If you wanted to call native methods from within Java, you basically are running outside of what they call the sandbox. And what you're doing is you've built in, and this is one of the few reserved words we don't cover normally in a Java course. The reserved word is called native. And when you declare a method as being native, you provide no interface, no implementation, rather, and then in order to get the implementation, you do a system.load library. And this gets done in a static bracketed method right in here. And if the library can't be found, then your program is pretty much dead in its tracks. So you compile your program normally, and then you use Java H hello, and that will take the native methods and create C++ header files, which you can then include in your C++ program. So once you've got that done, then your native methods have to be implemented. So you go into the C++ program and find a way to map from the Java data structures into the Java native interfaced headers that were supplied for you with the Java H invocation. The compilation, well, this is the tricky bit. You need a tool chain. You've got to recompile for every platform you intend to target. And then you have to do deployment for every single native method that you plan to deploy. This can make deployment using Java Web Start, for example, very complicated, because then you've got to include jar files that contain compiled code, which then must be signed. And it has to be made available for every platform you plan to deploy on. If you're running these things from the command line, you can simply set up the load library path to the shared object library, and then things will just run on one platform. But if you truly want to get multi-platform capability, it's a rather more difficult problem. The mapping of data types is also tricky. C data types are typically platform dependent, and Java data types are not. So JNI requires a portable C data type, and it makes its own. And there is a mapping that occurs between one data type and the other. So for C's counterpart, in any single one of the 8 different Java data types, Boolean, byte, character, short, int, long, float, and double, we've got a corresponding J, Boolean, byte, character, short, int, long, and double. And these things have a size which is relatively consistent with our idea of how big things should be within Java. So then we've got a question of how you map strings. The Java uses Unicode, which is a 16-bit quantity, whereas C uses an 8-bit ASCII code. And so there's no simple passage of memory from Java to C, and therefore you have to do some sort of mapping. So then comes the next question: what happens to the environment? And what you're getting is a pointer to a complicated data structure, and you have to navigate through that data structure using com.sun.structure API. So there's a special class for that. The string which is being passed in through a pointer is coming into a thing called the J string, and this is one of those elements where you end up getting sucked down a rabbit hole, really, because you're dealing with bytes instead of 16-bit quantities, and so you're really looking to take the string and convert it into an array of bytes. It so happens string has that ability. You can do a get byte array from any individual string, and that can facilitate the conversion. And then, of course, if you want to go beyond numbers and strings, things can get even more cumbersome. So here, for example, we have a class called employee, and he looks like he's going to get a raise of a certain percentage, and now I want to implement this as a native method. So first thing I want to do is a JNI export, and I create the so-called JNI call. So we've got our own little library that we can link to within the C++ or C program. The argument JObject is a non-static object, and in fact it is like the this method. So you're passing an instance of the class in, and now you have to access the parameters in the object in order to be able to get access to the salary field. So this is going to make life rather more complicated for most individuals who are not real familiar with C and C++. But the star is used to symbolize an address, and this is going to allow us to gain access to various data structures inside of the Java class using getters. But we have to do that getter invocation by using a pointer. So we go into the environment, grab a pointer, and then do an invocation of the get field using the environment, the class instance that we're trying to get, the field ID we're trying to get. Then we can finally return a value and set it equal to x. And this is cumbersome, as they say. Cumbersome. So we got to do the same thing for something like salary. Here we have a salary with a field ID, salary, and we're doing a getter, and it's coming back as a double, so we put in a D, and now we use JField ID, and the ID comes in. Here's another example where we want the raise. So we're going to do a call of the employee raise salary, and then we put in the J double by a certain percentage, and then that gets invoked so that it can proceed to do salary star equals 1 plus by percent, however you raise the salary. Static fields are similar. You have to go in and get different objects by fully qualified class names. So here's system from java.lang.system, and you can grab onto the out instance, which is an instance of the Java IO print stream, and you can call out.println. And so now you can call back on the Java methods. And so one thing you might like to do is call the methods with implicit parameters and some method ID, and then the methods can be invoked from within your C program. So Java can call C, and then C can call back on the Java. And so there are these various letters which we see, which are supposed to represent the primitive data types: capital D for double, capital Z for Boolean, capital V for void, and L, and then the class name for some class type. And you might have to deal with arrays in this way. So you could say something like L and then D, and that would be an array of double. So here's a java.util.date, and that's an instance of a class which is being passed in to some employee. And as it happens, you may need that for some reason to timestamp the employee record when it's created. When you see something like L Java lang string, that means it's a reference data type. Here we see L/class name. So then we see, what does V describe? We look at V and we say void. So that means it's a string, and it's being used as an argument, and that the return value is void. JavaApp is another tool that can produce field signatures. It's in the JDK, and there's a man page for JavaApp, and you can use that to help you create some of your Java native interfaces. And what I like to do in something like this is take a quick tour of the JDK and make sure that the JavaApp program is available, and it is. And you can type man JavaApp, and you can see it's a class file disassembler. Now in IntelliJ, you don't actually need to use the disassembler JavaApp because you've got something built in. So for example, if you wanted to look at hash map, you can automatically decompile hash map, and it'll come back to you using control. Well, in my case, it's moth B. Here's an example of something that was decompiled from the ComSun Java native architecture called the structure, and this enables you to navigate through native structures, and that's for native methods, which we can talk about in a moment. A native method architecture. So when we start looking at arrays, we see J Boolean array, J int array, J double array, J object array. There's a few others. And when you start to look at the array methods, that's when you start to see how array methods can be used. What you might like to do is come up with a simplified interface to the C library, and then do your invocations with a relatively smaller interface overhead. And so I've got a few examples that I've worked, and some of these are done using Java native methods, and others are used using Java native interface. The native architecture, I should say a few words about that. Native architecture is a slightly different approach to Java native interface. And what I'll do here is we'll see if we can bring up the serial port interface for RxTX. So what I've done over in here is I've come up with a COM driver and a serial port that enables you to load native methods directly. So here what you have is a serial port API that allows you to define the number of start bits, stop bits, parity, and flow control. And this sort of thing is so important when you're doing communication to an underlying device. This is called the clear to send. This is data set ready. This is the ring indicator. This is carrier detect. There's a way to gain access directly to serial ports and then proceed to communicate with underlying devices. I do this for the Arduino, for simple modems, things like this. So native methods become important for doing elementary work in the area of I/O, point-to-point protocol. So here's an example of Hello World. We'll do the Hello World example. And this is using Java native architecture. And that's the more modern version of Java native interface. And what we're going to do is we're going to do C library native.load, and then we're going to attempt to invoke printf, and we're going to try and write Hello World by invoking the printf in the native library for C. Let's see if we can do that. So here, if you wanted to decompile platform, you can see how platform has been made relatively multi-platform. And down here, here's Hello World being printed out using printf. And this was decompiled. In IntelliJ, if you type Control-J, you can not only see that it, the documentation on platform, but you can see what jar file it came from. Let's do another example. There's a portable operating system software interface library for Unix called POSIX. And here what we'll do is we'll use POSIX to make a directory and then actually change the readability of that directory so that it's read-write to everyone. That's what the 777 means. So now if we run that program, we should be able to go out into the temp directory and find the directory called rename dir. Temp directory. Oh, there it is. So rename dir is here, and it has a 777 access almost. I don't think I had permission to do 777 for everyone, so it didn't allow it here. let's see if we can change it to something else. Or better yet, let's remove the rename and just make new dir. And here's new dir. You can see once again I was not given the 777 permission. And that changes things radically, right? Because now we have 777, whereas before we did not. So within the Java platform, I was not able to gain full access to changing the settings on the directory, which is, I think, most interesting. But we do have some capabilities. For example, here we have an interesting program that has access to the serial port. We can go straight into the serial port setup, choose any one of the serial ports, and we can even test it for its ability to dial. Not something you normally are able to do within a Java program. And that's accessed using Java native architecture. So that's kind of cool. If you wanted to be able to store your settings, you could create a data structure, as I've done here. I've created a series of serializable instances called beans. Here's the baud rate bean, so once you select a baud rate, that can be saved, and it gets saved out to an area that automatically populates your graphic user interface. So when you go back to the graphic user interface, you can see that the serial port settings are retained from the last run. Pop-down choices, baud rates, the data bits, no parity, number of stop bits, and flow control have all been retained. And so what that means to me is that I'm able to call a variety of phone numbers, and these things can be automatically dialed. The aspect of using native methods frees the Java programmer from being constrained by APIs that are just supplied to you by Oracle. You can toggle specific hardware lines. Here's a DTR test line. That's the data transmit ready line. When you toggle this, you've got a plus minus 10 volt toggle coming out of the serial port. And this enables you to do a lot of different interesting sorts of controls where you're toggling outputs or listening to the ring indicate. You can even sense busy. So interfacing to a variety of different languages is possible. It's not just limited to C or C++. You can go to Fortran or any other language you like. The trouble is, of course, passing data is much more difficult. And what you'd like to do is find something that allows you to invoke the native methods without having to go through all this trouble. One way to do it is to go straight into the executables. If you have an exe file, you can invoke it using a process and call runtime.exec, and that makes life a lot easier. Then you can get the input and output stream, you can kill it, you can halt it, you can do whatever you like. Runtime exec's not as fast or as low level, but it is a way to go, and it may be useful in some cases. With the Java native architecture, which is a much smaller native library using a so-called foreign function interface library, libffi, you can dynamically invoke your native methods without having to do a whole series of heroic loads. The loads end up becoming a rich source of fragility, especially when you're deploying Java Web Start. So with the Java native architecture, you get a Java native interface by a proxy. So he creates what is called a DLL proxy, which then does an invocation. And so JNI provides you with a JNA.jar, which gives you the ability to dynamically load the proxy library so you can do your invocations. And you can get to DLLs for Windows or .so files for Unix or the Mac. Now you've got different mappings. Now you've got to go from Windows to the Java byte to the native types. And in fact, the mappings aren't all that different from what you've seen before, except perhaps the strings and the pointers. Those look a little bit different. And there's a special class called the structure class, which enables you to access these. The limits to what you can do are typically governed by what it is you can program in C. So if you can program it in C and you can use JNA, then you can basically have access to a series of different functionalities that you might not have had before. For loading native libraries dynamically, I've created an entire API just for doing that. And there's even a native library manager which will allow you to initialize your boot path dynamically and thus load things by finding them when needed. Moreover, I have a native loading transporter which can load native libraries as needed. So here we're loading up Java 3D so that you can have the Java 3D libraries in case they haven't already been installed on your system. The big challenge, I think, with any type of computing really is configuration. If the environment is configured differently and things stop working properly, your tendency is to blame yourself, but in fact it may be your environment that stops things from working. So that's what I have for you for native methods. Hope you like my little presentation. Thank you.